Hi, welcome to this video with my RPi1 and 2 doing LED play. And as you can see, I have some LEDs here. 3 connected to my RPi2, 3 connected to my RPi1, and they are supposed to signal each other to burn. Last time I found out that although the algorithms are now the same, supposedly to be the same, the speed of burning when I let them burn after another, so the RPi2 side next to the RPi1 side, there is a slight difference in speed, and I'm not sure what that causes, but it is about LED play, so one LED on the RPi1 side and one on the RPi2 side. Strangely enough, when I go here on the RPi2 side, as you can see, the second and the third LED are commented out. Not so for the RPi1 side, not so for the first LED. Going to the RPi1 side, running Python, the idea is that, as you can see here, if GPIO input 11, and yes, that is really GPIO pin 11, is up or made high or whatever you call it, then RPi1 side output 7 is put up or made true and starts to burn for 2 seconds and then set to off. So in order to do that, I have on the RPi2 side the LED pin 7 go on, burn for 2 seconds and then go off again. And when looking at the wiring on the breadboard, then that should be okay. So the question is, last time I just put it on and it turned out to be blinking without interference by visible interference by this input, because whether I ran this program or not on the RPi1 side, it just kept blinking, and that is not my idea of LED play. So let me run on this side the program again. If it chooses to work anyway. It is LED, it is this LED. It's hardly visible, but if I put it down you can very vaguely see it burn, and yes, the problem is that it shouldn't do that without RPi1 running, which it clearly doesn't. As you can see here, the command is there, but it's not executing yet. So I'm stopping it, and I'll have to find out why it does that. This on the other hand, reasoning, this one should be going on and off. It's the other one who should be influenced. So let's run this one. Yes, run as root. Is this activated or not? Not really. So it's on the RPi1 side that should be influenced. And quite annoyingly, as I will show you, that just is not happening. So let me show you on camera. According to the code, this side should be influenced by this side, and in the way that from the RPi2 side, which is blinking rightfully because the program is running, to the pin 11, and if that is high, this LED should blink. However, no such thing is the case. Now it could be that the LED is broken, but I highly doubt it. In order to test this, I can remove the if statement, so let's do that for a moment. Run it again, and as you can see, LED on RPi1 side is nicely burning, so I'm going to put the if statement back. And that brings me to the question, why doesn't it burn? Which could be the fact, let me just start running it. And right now I'm just mingling the wires. And that is a little bit odd, because according to the code, if signal on 11 is high, then the LED should be running. That said, there's another thing I didn't really think of. So because this LED is going on and off as well. So let me first let this one burn steadily and then see what happens here. That seems like a good plan. So, since the RPi2 side is influencing the RPi1 side, I will add here let's just see how to do that, how to do this in a good sense. I think I should make the change on the RPi1 side. So if this is true, put it on and let it but if it is 0, I think that is the solution right now. So true and sleep. However, if not GPIO dot input 11, let it be false and sleep for 2 seconds. And I might even, yes, but I could take the sleep away, but then it is an ultra short flash. So I think I'll keep it for now like this. So let me run this again. I don't have to change this. So just run it again and see what happens. And surprisingly, unfortunately, I think not that much. And you may see this still not clear to see, so I'll use the camera again. So with the changed algorithm, whenever this LED is burning, this signal gets high and the LED should burn, and whenever this one is down, the signal is down and this LED is down. However, it is not doing anything. So the big question now is why, and I think it is time to get multimeter to check for a signal. So that signal on the RPi is 3.3 volts, and that means should I use the analog multimeter again and see what that gives me. And point is then what is the ground, and the ground, let me use that for let's say here, this is the ground, or is it? I think this is rather the ground, and then this signal and let me show this on camera, because this is nice to see. Let me see how I can put this nicely. So this is the multimeter again, and this is the signal. And since it's behind a resistor, it's not exactly 3.3. But you can see how the signal is definitely there. So let's check on the actual pin 11 right there. Let me turn the camera again. So this is right here. And then I find I've made a small mistake in thinking, because this is a wiring mistake. I haven't wired the pin 11 to the connector to the RPi, so that is why it is not working. Reasoning in this case is everything. So let me wire and then see that it probably will work. After using the multimeter, it becomes clear that it is a wiring issue, and as you can see now, LED burns and the LED burns and goes off and on. So the idea now works. There was a slight problem in the algorithm, because when I turn it on and off, well, this one is turning on and off. That's a problem, that won't work apart from the wiring. So with this one turning on and off, and this one with a double if signal is high, go on, if signal is low, go off, that clearly works. And with that I can get on putting wires in. The only point is that I need a couple of more wires to put every signal through. So let's see how that works out. So with this problem found out, I do need to change the algorithm here as well. So let me first get rid of these comments. This can be get rid of as well. And then this as well. Thank you very much. This needs to be copied. And then, very important, another if not after which of course follows this one. And then the time needs to be copied again. And another if not. So this is done for now. Now do I have to change it here as well? I do think so. I just for the first nice stage I have to do some rewiring as well. And then it won't be a full LED play, but two LEDs influencing each other more or less after another. So let's see how that works out. First save this. I want to see what I'm typing here. Yes, right. Then I have to compile again because this is C++. No errors as expected, because I just removed some comments. Here everything should be in order, but let me check it anyway. That doesn't matter. There's no real error so far. So it is time to do some wiring, which means that I need two more jump wires. So let's do that. For now, let's just follow the same strategy as here. So I have to relocate this wire, which stays in 16, but it has to go from 16 to the band cable. So this is 6, 8, 10, 12, 14 and 16. And the same goes for wire 31, which has to be relocated here. And then with the substitute, because I'm out of orange jump wires, and I hope it stays put, which has to go to 31, which is in all kinds of logic here. So hopefully everything is set now with jump wires, and let's see if that really works. Oops. And it looks like it's not working as intended, except here it is working. Now that is working, and it would be nice if this would be working as well. And that is working. I only don't see this one working, which is weird. So it works, and yet it doesn't work as I like to, because now this burns and this one doesn't. So apparently my algorithm isn't working the way I want. So let's check it out. So it kind of works, and when I'm looking at it, just like you saw, it at times it works the way I want, and at times it doesn't. And I think I should change the algorithm here as well, but also the wiring, to make sure that if this one is high, it starts here and not earlier, and I would need 3 more jump wires to do that. I already have here some inputs defined, so here it says simply for 1, right after that it goes here, and right after that it goes here. This is sequential logic and not parallel logic. Like in parallel logic is, for instance, Verilog and VHDL. But that's a far cry from what I'm doing here. So basically the algorithm works, but like what I like, I need some more jump wires, and I think that involves some trickery. So let's find out how I can do that as well. Let's first do something else. So if input, let's go back, if this one is going fine, then go here, and that would be the nicest one. But then again, there's a difficulty in doing that, because when I put all LEDs after another, side by side, Python against C++, there was a small difference in the way they ran, and I think that is going to be a problem as well. So how to solve it, I don't know yet, but let me first do some wiring. Yes. So with all jump wires set, and I had to use some preformed jump wires from this set, and a correction in jump wires for this LED. Let's see how it runs. This runs fine now. I had to set this one straight. This one runs fine, and now here again. That is not so nice. There always seems to be something not quite alright. But overall, now you see that the first stage is going quite nice, except for this LED. And why this isn't working, who knows. It won't be defective. But the idea is, I think, clear enough. So with all jump wires here and here, it is also set to influence from here to the other side, and I think I will leave that for next time. So thank you for watching, and to be continued, obviously.